Entonces ahora ya está. Now? Now, perfect. Okay, so first of all, thank you very much for coming today. Yeah, well, we're revamping or restarting, for example, what's the SAP Inside Track Madrid. So yeah, this is the first time. The first one was in 2019, and now this is the second one. So yeah, hopefully we will be able to actually do it year after year. So as you've seen already, we have a big column in front of us, which is not a problem. It's a feature of these rooms. So yeah, so unfortunately, like the speaker will need to move a bit, and yeah, it's not ideal. But well, welcome, and yeah, I hope that everyone has a nice time today. We have how many sessions? Like 9 sessions, for example, for you today. Every session will be around 25 minutes long. Then there will be a bit of a QA, something like that. We'll try to squeeze it as much as possible. But yeah, welcome. And our first speaker for today is DJ Adams. So come on over, DJ. So thank you.
Thank you very much. Yeah. Does that clip on?
And welcome to everyone that's on the live stream, because we're
streaming
this live. So yeah.
Welcome live streamers, live stream attendees, and yeah, thanks Antonio. By the way, we christened this column yesterday, because it's a column, we christened it Hannah. So welcome Hannah as well, and welcome everybody. Thanks. Antonio, you told me I had an hour. No, I'm just kidding, just kidding. Just kidding. Okay, so I'm going to start off. Oh, I'm going to ignore all these sort of person entered waiting room admit. I'm going to hit admit anyway. Let me get out of here. So what I want to do is just talk to you today a little bit about, let me just do that here as well. I've got actually a blog post as well. Ooh, that's a bit big. Let me do that again. There. So I thought I'd generate a QR code in the terminal. I wrote a little Docker file this morning to do that, because I thought that'd be quite cool. So you can access the stuff that I'm going to talk about in written form. So you can all do it as homework tonight as well. So basically, if you miss something, or for those watching from the live stream or whatever, you can follow along like that. So what I want to talk about today is the CDS repl. How many folks know about repls? Maybe it's just because you're not as old as I am. Basically, the concept of a repl is a super old concept that came from really the sort of late 1950s, 1960s, in language environments such as Lisp. I'm going to make this a little bit bigger. Basically, also in the blog post, let me just attach to my talk repl, my talk container. Make that bigger, 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 bigger. There we go, fine. Okay, clear. So everything I'm going to do, you can do yourself as well, and follow along the instructions in the blog post just to practice, because it's all about sort of fingers on keyboards. And repl is an acronym: read, evaluate, print, and loop round back to the start. So basically, it's like an interactive way of talking to something. Back in the day, it was the Lisp interpreter, or Ruby has a repl, Python has a repl, Node has a repl, and we'll start off by looking at the repl in Node, where you can basically type in JavaScript and it will be executed, and you'll get the output back, okay? So the CDS repl, this is in relation to the SAP Cloud Application Programming Model, if I don't need to explain that at the start, allows us to interact with the Cloud Application Programming Model facilities, the API, the API landscape within CAP Node.js. Why is that important? Well, it's important for us as developers, so we can sort of explore and understand a little bit more and play around and have immediate feedback. Okay, that's the beauty of a repl. It's immediate, and you can explore, and it's very easy to get into. Okay, so we're just going to have a little bit of an introduction to the repl. I'll show you how to get into it, a little bit about querying, exploring the sort of the core data structures in CAP. And we'll do, maybe if I get time, a little bit more interesting stuff, like maybe create our own little server and also maybe connect to an external server. For those of you at the Code Jam yesterday, that might ring some bells as well. Okay, so what I've got here is a terminal, obviously, because the future is terminal, and I'm running a container, because I run everything in containers, that has 8.8.1 of CAP Node.js in a Debian container. But all we're going to do is and I've also cloned the repository from the SAP samples. This is all in the blog post as well. Cloud CAP samples. So it's got bookshop, bookstore, other things as well. And we're going to be using the bookshop as a little bit of a CAP service to sort of play around with when we need to. So that's where it is there. There's the bookshop. Now, I said that Node has a REPL, Node.js, JavaScript runtime, server-side JavaScript runtime. And you get to it, you might have got to it by mistake by typing in Node. And that's what it looks like, okay? It's a nice little prompt. If we look at help, for example, .help, basically, you get certain commands that are sort of like meta around what you want to do, okay? So you can escape from things, you can sort of exit, you can load little bits of JavaScript, and you can also, save sessions as well. Now, if we abort out of that and instead remind ourselves of what the different CAP Node.js commands are with the CDS command line tool, we can see that one of those is REPL. So let's start the REPL. CDS, let me clear the screen here. This zoom thing is in the way at the bottom. CDS, you can probably see it best at the top anyway. REPL. Okay, a nice simple prompt. It's like, oh my God, what do we do now? Okay, so help. Looks familiar? That's because it is familiar. It's basically Node.js REPL++. Those who remember the previous help commands will notice that there's a couple more. There's also .editor. I don't know why it didn't appear on the Node.js one, but anyway, .editor is part of the standard Node.js REPL. The CAP team have added, or Daniel has added, the .inspect, which we'll look at, and the .run, which we'll look at, okay? Now, basically, the .inspect allows us to comfortably view at different levels of granularity. You can turn it all the way down to 0, all the way up to 11. That's a reference to a film. Anybody know what that reference is, by the way? It's in the blog post. Who said that? Spinal Tap? Anybody? Spinal Tap? Oh, anyway, that was a culture reference lost here in Madrid. There we go. Anyway, so we can actually inspect structured objects with the .inspect, and we can also start up a CAP server, because of course at the moment there isn't really much for us to play with. We can say 2 plus 2, that's 4. That's just regular JavaScript, right? Okay? But we can say here CDS. So CDS, you might have seen in the documentation, in the Capire documentation, CDS gives us access to the entire API landscape. It's often referred to, is it me or is it really warm in here? It's often referred to as, is there any air conditioning? Whew. The CDS facade, okay? And if we have a look right now, it's quite small. One of the reasons why it's quite small is because, like many things in great programming environments, I'm thinking of many functional programming environments, stuff happens lazily, i.e. they're not evaluated until they're actually required. So we start out quite small. Okay, so if we were, however, to say, well, what's in cds.env? I mean, .env is not even in that list there, but cds.env, the .env is basically the environment, the runtime configuration, consolidated configuration for all those different things for a CAP server. I mean, we don't have a running CAP server right now, but that's okay. cds.env, loads of stuff, right? All that stuff here. And this is where, for example, the .inspect comes in. But now, if we look at CDS now, that's also exploded because it also contains the env that was lazily loaded just now on demand and now is huge because, of course, there's a lot of stuff in env. Now, because we've got the .inspect, we can say .inspect CDS. Of course, that also shows us everything because the default sort of, granularity of the .inspect is 11, right? Wow, loads of data. So we can say, for example, here, .inspect and then .depth equals 0. And we sort of bring it down again, okay? So we can sort of, contract and expand and not worry about thinking, oh my God, there's so much stuff to read through. I'm never going to sort of, even get my brain into this whole thing. So we can also, for example, start up a CAP server. Okay, remember that I cloned the CAP samples repo. And so I've got, for example, in the current directory where I've started the REPL, I've got the bookshop directory, which has appdb and serve in it, and the package.json and everything, and there's bookstore and everything. So in the days before major version 8 of CAP Node.js, you used to have to use this sort of weird cds.test bookshop thing. In fact, you had to await it as well because everything's asynchronous, and that would start up the CAP server according to the configuration in bookshop, which is pretty cool, okay? But there's a lot more of a convenient way of doing that sort of thing. Let me exit out of the REPL, go back in again. Of course, the server's not there anymore. We're back to sort of square one, okay? I can say .run. This is this new sort of command that's been added to the Node.js, .run bookshop, okay? And that's a lot simpler. It also gives us a couple of other things, which I'll show you shortly. There's an equivalent of that as well. I could say cds.repl and look, help. I could use the -- run. So cds repl -- run bookshop. So that's another way of starting it, that's fine. Okay, the other cool thing that the .run or the -- run gives us is some really convenient, there's my glamorous assistant when I need them, convenient variables, okay? Anybody who's sort of played around with CAP generally will know that two important sort of lumps of stuff are the services and the entities. Oh, look, entities and services. And what it does is it will expose these as variables that we can then access directly in the REPL to have a look at those, okay? Even if we don't, because what we don't want to do is think, oh yeah, I can only use sort of CAP REPL affordances inside the CDS REPL, in the CAP REPL. I'll sometimes say CDS REPL because it's called the CDS REPL in the documentation, but in the CAP Node.js REPL. But you can also use any sort of JavaScript to do anything you want. So I could say, for example, here, object.keys cds.entities. Hey, looks familiar, right? Looks familiar. I could even say object.keys, just CDS itself and start exploring what I have, okay? You can only get to a certain point really when you're exploring until you sort of get a little bit bored of, okay, well, I've looked at this and looked at, for example, cdsenv.plugins. You can sort of say, oh yeah, what are the plugins? Plugins, if I could type, there we go. Now, that's interesting as well. In fact, in the blog post, there's a link to a mini-series about how to build your first CAP Node.js plugin. And that was a plug. See what I did there? I just thought of that. That will also explain why we haven't even started a server, but we've got these two plugins, because those, the CAP infrastructure itself is built using plugins. It's amazing. Anyway, let's have a look at something that we might sort of stumble over. Let's actually start did I start the bookstore already? Oh, I did start the bookstore, yes. So let's have a look at cds.entities. Oh, that's a bit underwhelming, isn't it? Okay. Why do we get that? It's because the entities are sort of exposed via the CDS facade as a linked definitions class, which is an iterable in JavaScript. So you can't just go, oh, show me the things, okay? However, with .inspect, I mean, if you knew what was in there, for example, with object keys, did I do that already? Object.keys.cds.entities, you could say, for example, cds.entities books and go straight to it, okay? So there's lots of different possibilities. I'm sort of almost like doing this to death in terms of the sorts of things, but I want to make sure you're comfortable, okay? Instead, remember we've got the inspect. So I can say inspect cds.entities. Oh my God, there's loads of stuff again. Like there's the elements, there's the entities. So what I could say, in fact, why don't I say .inspect set my default depth to 0. And now, that's better. Okay, right. So far so good. 9:42. I can't believe it. So we're going to move on to part 2. There's 4 parts in the blog post. We might not get to part 4, which is a bit disappointing. Well, maybe I'll just jump to part 4, I don't know. But part 2, I just want to introduce you to some querying, okay? So the querying, we've already got, in fact, let's bring that back again. Let's go out of here and do that again, just to remind ourselves of what we get for free, as it were, at the bottom here. We've got the entities and we've got the services, Okay, if you remember, and you can sort of imagine it if you haven't seen it, you know, the bookshop service has an admin service for the bookshop admin people and a catalogue service for looking at the books and everything. And it's got books and authors and genres. Okay. But what's this? DB. What the heck is that? Everything is a service in CAP. So we have the DB service as well. Okay. Anyway, you know, we can, if we had all day, we'd dive into all this stuff, and I might actually take over the day and just, no, just kidding. So with these different things, we can already start to think about combining them. You know, we've got these things at our fingertips. So let's say catalog service dot read. There are many query APIs, which can be confusing, but actually when you sort of stare at it for a few minutes, it becomes like this nirvana. You know, you can use the Fluent API, you can use a sort of a SQL style API, or just do something like this, you know, read, and then what I'm going to read books. That's also a reference, that variable, okay? Oh, what happened there? What happened is that we didn't run a query, we created a query, we defined a query using that particular, the .read sort of approach to building a query. And this is what you'll find when you sort of start to embrace the REPL and mess around and explore. It's really important to understand, for example, I don't want to turn this into a lesson about CAP generally, but queries are super important, and they are first-class citizens. We touched on this yesterday in the code jam as well. So I could even assign that my books equals, okay? So I can pass that variable around. It's a first-class citizen. How do I actually run the query? You know, that's a little bit boring. Oh yeah, select from. Oh, it's really interesting. So await my books. There we go. Because everything in CAP is a service. Everything in CAP is an event. Everything in CAP is asynchronous. CAP Node.js is asynchronous, okay? So we have to sort of await that query object to say, go and be executed. Does that make sense? We can also, for example, and let's reduce the query, because as you saw, I didn't really specify any elements to return. So it's of course returned all the elements for all the records. Okay? Records, I'm showing my age there. Records, fixed record length. Anyway, so for example, we could say instead of the catalog service.read, we could say, for example, you could use a CDSQL function or constructor. QL stands for query language. So I could say CDSQL and then pass it a template string. So I'm going to try and do it sort of properly with uppercase for SQL and everything. It's not what we're writing here is not SQL as in SQL. It's SQL as in CQL, which is SQL++. Again, if you watch the Art and Science of CAP series with Daniel Hutzel and me being an idiot, I'm the idiot, not Daniel, you'll find out all about the difference between, for example, how CQL is SQL++ with path expressions. And anyway, let's not go there, DJ. So select ID and name from authors, for example. Again, we've constructed a query. That query is just sitting there saying, hey, I'm a query. I could say, all right, well, actually, I want to run that. Okay? Hopefully, you're getting to feel a little bit more sort of au fait with, comfortable with what we're doing here. So let's move on a little bit. And in fact, let's have a look at something that's close to my heart, coming from, the one true programming paradigm to rule them all, which of course is not object-oriented, it's functional, right? Of course. So I'm still waiting for ABAP to go functional. Then I'll go back to ABAP. Think of queries as first-class citizens, as I've been hammering that home. So I could say, for example, well, actually, let's do this again. Where's that catalog service.read books? My books is that, right? Okay, fine. Or in fact, let's do another one. We'll say book titles equals catalog service.read title from books. Okay? And then I can await it. titles. But also, I can take that query object in this book titles variable, and I can riff on that and expand it. It's dynamic. So I could say, for example, await book titles dot where, oh my God, and then have a condition, author underscore authod ID. Those who know and love the bookstore will know that author ID 150 is Edgar Allan Poe, I think. Anyway, doesn't really matter. Just some random thing. There we go. So we've actually extended that query by adding on dynamically a where clause. Okay, and we've qualified that with, you know, the author ID. Note that the author underscore ID comes from, of course, for those familiar with managed associations. Managed associations are managed in the sense that it does a lot for you, including generating the name for and managing the values for the foreign keys, author underscore ID, based upon, of course, the association name. Okay, so I could, of course, assign that as well to other things. But anyway, I want to dig deeper, right? Because we've got 9:49, we've got 25 minutes, I've got 5 minutes to go, 6 minutes to go? Okay. So we haven't really even scratched the surface, but I'm hoping that you're getting a good impression as to there's nothing scary about this. You can play around, you can't break anything. So let's go one step further and think about, well, if we have a look, cds.services, that's not a linked definition, so we can just do this. Services, we can say, well, let's put the depth, inspect depth 0, inspect CDS services. There we go, boing. We've got the 4 services. Remember we saw the 4 services exposed to us when we did the .run, including DB, admin, and catalog service. We could, for example, say .inspect catalog service there, .handlers even. Remember, for those of you who were here yesterday, you're my favorite people. Not that I don't love other people. No, I'm just kidding. .handlers, in fact, .depth equals 5. Check it out. We can see all the handlers that already exist for the catalog service. And for those, again, who are more familiar and maybe have done a little bit of CAP Node.js in the past, or CAP generally, we have before handlers, we have on handlers, and we have after handlers. And they do what, you know, they do what you can imagine they do, the before phase, the on phase, and the after phase. Now, why don't we create, because we can, our own service randomly to explore not how we would create a service dynamically on the fly for real, but to understand more about what services actually are and how they work. Okay, the REPL is great for exploring and teaching yourself stuff. So I could say, for example, S, because I can't be bothered typing, S equals new cds.service. Okay, fine, we've created a service. Whoa, that's it, end of talk, thank you very much. No, just kidding. So we can now say, I want to add a before handler. What event do I want? Now, of course, you know, we're all used to seeing things like read, update, delete, and whatever, or, you know, we have also, because OData is not purely RESTful, it has these weird sort of orthogonal things like, you know, actions and functions, which are just horrible, but okay, let's just deal with it. Submit order, we saw that just then, right? Let's create something randomly, SAP inside track Madrid. And we want to say, for example, well, when that event comes in, let's say, I don't know, let's have a fast arrow function, console log, hello. Okay. Let's also have an after one. Goodbye. Let's do goodbye. Bye. And that we'll have after. So we have a before phase that gets called for events before the main processing or handling of that event takes place, and the after is the after, of course, and then the on is the handling of. Okay. So in fact, let's do that now. So s.send banana. Now I'm doing this deliberately. life, universe and everything, 42. Let's send it some data, a payload. We just get a promise, okay? We don't get anything. Why don't we get anything? Because we've emitted. I'm sort of mixing up deliberately. Go and see the Art and Science of CAP and read all the blog posts, a really long blog post. Who said it was too long to read yesterday? Please leave the room now, just kidding. We've sent an event called banana, or banana. But there's nothing listening on banana. We're listening on SAP and sitmad. So let's do that again. Sitmad, sitmad. Let's clear screen. Hello and bye. Let's create an on handler because we're feeling brave. S.on sitmad. And I'm going to use the old-fashioned function definition because we get that nice sort of arguments pseudo variable. We can just like splat out everything we get past, which is quite good. So we'll say console.log got arguments. Send sitmad again. There we go. So what gets passed to the on handler is the request itself and then the asynchronous function next, okay? And you can sort of see how with this dynamic creation, randomly, it's like making, I almost said the rude word then, making stuff up really helps you get a closer feel to what is going on in the CAP server, and therefore hopefully will make you a better CAP developer. Now, how long have we got left? Is that it? What?
6 minutes.
6 minutes. Okay, brilliant. Okay, brilliant. So, all right, have a cup of coffee. So, any questions, by the way? Any questions from you, Hannah? No. Okay. Right. So, just because we can, I've got a remote service. In fact, what's it called? Let me find it in the browser. Let me open new tab. What's it called? North Breeze. There. Right. So if I say curl, that one there, we've got a no data service that's public. Okay, North Breeze. It's a cut down version of North Wind. Get it? North Breeze. Right. So products, suppliers, categories. That's pretty much it. So it's sitting there ready for us to make calls to. So why don't we, let's close that again, why don't we go back and see if in these 6 minutes we can actually connect to, define that as a service, as a required service. Remember that yesterday, required and provided services, and connect to it. Let's see. What we need to do, of course, is install the SAP Cloud SDK, npm install SAP Cloud SDK HTTP client. We'll do that first of all. And then let's go back into the REPL, CDS REPL. R is short code. Now, cdf env.requires depth equals 1 dot inspect. So at the moment, we're not really requiring anything other than the basics. We haven't even started a server. So all we're requiring is, with a SQL-like sort of database persistence layer and some auth, that sort of mocked auth, remember that from the startup. But what we can do is we can say, for example, breeze nb, that's too long to type. Await CDS connect.to, a link to this API endpoint is in the blog post. Let's call it North Breeze. And then we can even help the machinery by giving it the binding information. Remember that from yesterday as well? It's all tied together in my brain here somehow. I'm not quite sure how it's working, but anyway, kind. So it's a kind. What type is it? OData. And then we've got credentials. Oops, no, credentials. And all we need really is the, what do we need? The URL, which is in my paste buffer, thank God. Right, there we go. And that's that. Close that, close that, close that. That's a lot of output, but that's not a lot of error output. So maybe we're okay. Now, let's have a look. let's define a query. Let's go back to what we learned before. Categories. Remember in North Breeze we got products and categories and suppliers. So categories is a short, entity set. There's like 8 or 9 categories. Category equals. Let's construct a query. A standalone thing that we can send to external services or send to the internal persistence layer. So we say, for example, here, select category name dot from categories. I'm doing it deliberately also in a slightly different CQL construction API. Okay. Now, if I were to say, for example, await, like we did before, await categories. Woo, come on, DJ. What that will by default do is send it to the default database. But we haven't got a default database. Obviously, I'm not running any default service. But what we can do is we say nb.send that query. Is this going to work? Oh, that was suspenseful, wasn't it? I forgot to the await. There we go. Right, and with that, thank you very much. CDS REPL, it's amazing. It really helps you learn and feel and get closer to what's going on underneath. Have a go. The blog post has got everything I've done and more. So that's it. Thanks very much.
Okay. Oops. Okay, hello everyone, good morning. Thank you for having me here at this second edition of SAP Madrid. I think it's very interesting to have again this kind of events. So big thanks to the organizers to make it that possible. Okay, the topic of my talk will be knowledge graph. I touched this topic in the last SIT Barcelona. Some of you actually probably are familiar with this presentation. At that time, I present a knowledge graph as a way, an alternative way to to grounding LLM models or foundation models. GenAI use just only one single model for everything, like narrow AI, and that has a challenge because probably your data or the data of your enterprise was not included in the training data set. So the challenge is how can we provide the context of our enterprise to the foundation model. One service that is now launching the SAP in BTP is document grounding. But I think, and what you have to do for grounding The foundation model is just to extract the information from your database, from your system, to convert to documents and to apply the natural language algorithm in machine learning to extract the entities, to find out the relationship between the entities, and create a new vector embeddings to store in a vector database. And instead of querying the foundation model, you query the vector database and by similarity find the correct prompts to be sent to the foundation model. But this process, in my eyes, is, okay, you have the information in a structured manner in databases, and you extract and put in an extract in documents for extract or for capture this knowledge. And I wonder, is there another way that we can do that? And the answer are the knowledge graph. So the talk is divided in 3 parts. First of all, a short introduction about knowledge graph, just to put everyone in the same page. And then I will give some glimpses about how to build a knowledge graph in SAP environments. And finally, this is different from Barcelona, I will show you how to use knowledge graph. I will present 2 cases. Okay, let's go. But let me first of all to position this technology. And for that, I used this Gartner report that is called Emerging Technology Tech Impact Radar that help us to know which emerging technology is getting traction, how it will evolve in the short term. For that, the report used 2 dimensions. One dimension, that is the time to adoption, is a kind of measure of the maturity of this technology, the time that this technology will take to reach the mainstream. And the other dimension is the impact, or to measure the magnitude of this technology in the industry, in the business outcome, and in another technologies. As you can see that the knowledge graph are classified as critical enablers. What does it mean? Okay, that means that this technology will help or will accelerate another technologies, and is considered as a base for accelerate the adoption of other technologies. So, but remember that the challenge we have is how to provide the context of our enterprise in a way that can be understood not only by humans. In natural language, normally we use the issue that natural language has is that there is ambiguity, there are paragraphs, there are irony, so it's not so easy to understand by a machine. So the challenge is how to represent the knowledge in a way that can be understood not only by humans, but also by machine. Okay. But before digging into the knowledge graph, let me review some basic concepts: data, information, and knowledge. What is data? Well, data is raw, is nothing else, has no meaning, simply exists, and we can find the data in different format. For instance, we see the data and we see the number 42, what does it mean? Well, depends. 42 could be the next integer number from 41 or the previous integer number for 43, or could be the age of my girlfriend, or could be the house number where I live. So to give some meaning to the data, we need to relate with something else. And when we do that, we transport the data to information. So information is data with meaning. That meaning doesn't need to be useful. It's just data with information. And normally it's contained in descriptions and answer to questions starting BW. Where, who, what, when, what, and perhaps how many. We understand by knowledge the collection of information which intent is useful. Yeah? And we understand by wisdom the ability to take decision or to make a judgment. Yeah? And the whole process from the transformation from data to information to knowledge and to wisdom is what we call understanding. Yeah? So, our challenge, how can we represent the knowledge in a way that can be understood by a machine without any ambiguity? Well, one way is using graphs. A graph is a collection of nodes and edges, and a knowledge graph is a particular case of graphs where we put entity in the nodes and we put the relationship in the edge. Yeah? And in this way, we can code the information. Perhaps one remark, this is important, the direction. Imagine, for instance, in persons as entities, we can relate one entity with another, like father, but in the other way, it's not father, it's son. So it's important the arrow in the representation. And how can we encode the information? Well, a naive way is using this formula, subject, predicate, object. And that is what we call triples. Triples are nothing else than subject, predicate, object, and it's a way to encode the information. Just to make it a little bit clear, I put here an example. In this use case, the intention is to put all the knowledge we have about birds, for instance. And we know that the birds eat plants, that the plants are living things, that the birds are animals, that the birds also eat honey, that honey is produced by bees, or bees produce honey, and the bees are insects, the insects are animals, animals living things. All what we know about this use case, we put in this explicit form. Yeah? Every connection is an information we have. And the whole collection of the information is what we call knowledge graph. And to store the information in this way, or to put the information in this way, is very powerful because we can see that we can infer things that is not explicitly in the graph. We can infer that the bees are living things, but this information is not explicitly in the knowledge graph. That is implicit. Yeah? So to represent the information, the knowledge in this way, help us to identify hidden relationships. Yeah? Of course, you can do it with relational tables, but it's not so easy to discover this hidden relationship. Another power thing of this is that is use case driven. What does it mean by that? Imagine that now some groups in your company is interesting to the provision of honey and add that information to the graph. So in this case, we are enhancing the graph, putting all the information we know about the provision of honey. We say that honey is a kind of product or a type of product. The honey is part of the purchase contract that our company has. That is included in a purchase order item, that there is a vendor that provides or that sells the honey. So we are increasing the information, the knowledge of the company without modifying anything. If you think about tables, normally you use an schema, and whenever you include new entities or new relationships, you have to change the schema. In this way, you don't need it, just to add the information as is there. But the next question is, okay, I create the knowledge graph with the explicit knowledge I have about this use case. is there another way to create the knowledge graph? For instance, normally we have a data model, we have the information in a table. It's possible to create the knowledge graph from that model. In terms of knowledge graph, we call this ontology. An ontology is a collection of entities and its relationships for the use case we are going to study. And in this very simple example, I put only 4 entities and 5 relationships to explain or to analyze an use case about provisioning. We know that a vendor is, or a product is sold by a vendor. That vendor provisions or provides the goods to the company buys the product. The company and the vendor are both located in some location. So we establish the data model, and for that, how can we create the knowledge graph? Well, the only thing we have to do is to apply our data, and we will get our knowledge graph. Perhaps some remarks about this is, perhaps if I work only in ontology, that is sometimes called metadata, I could create dynamically a way I can construct the SQL sentences to build the knowledge graph. And I think I didn't see yet, but I think that is the direction that SAP will be provide this kind of tools. So how can we store this knowledge graph? The only thing we have to do is to store the triples. In this case, I put Lidl as vendor, Honey product, Spain as location, and Sulzer España as a company. And now we have to go information by information, building the triples and storage in the knowledge graph. In this case, will be the honey sold by Lidl. The first one, the second one will be Sulzer España buys honey. That is the second one. The third one will be the Lidl located in Spain, and the last one will be Sulzer España located in Spain. So 5 triples to represent this knowledge. Good. The reason why we use knowledge graph to store the information, there are several reasons. The first one could be that is use case driven. I mean, I only have to put the entities and the relationship that fits with our use case. And it's very flexible. I don't have to modify the schema whenever I need to enhance the model, so I easily evolve with the business requirements. And perhaps, well, if of course you can do it with tables, but if you have to make the joins, the response time, if you have joins, increase exponentially with the number of joins you do in the query, and in the graph is almost linear. So we have better response is optimized for transverse the graph. Good. And that is important. There is a very powerful querying language that is available. Okay. You can think, okay, where can I store this information, these triples? Well, I'm happy to say that from the 1st of April will be available a new engine in HANA Cloud to store knowledge graph. At the moment, the kind of graphs that can be stored in HANA Cloud are called label property graph that are object-oriented, and even though can store the same information, it's a little bit different, and we cannot build the knowledge graph from the label property graph. Here I put an example. If we want to answer this question, the information stored in a property graph is using labels for the entities and using properties to store. But it's not the concept of triples. So in this example, that the person has 4 properties and the company has 5 properties, and also the relation has 2 properties. If we put this in a knowledge graph, we will have 4 plus 5, 9 plus the 2, 11 triples that have to be stored. And this is how it looks like in a knowledge graph. Perhaps you can wonder, it's possible to get the knowledge graph from the property graphs? Unfortunately, no. Other vendors that not SAP put a semantic layer between the property graph, and they are able to create this one. Let's see what is the solution of TCP from the beginning of the next one. Okay. Let's jump to the second part. That is how to build a knowledge graph in an SAP environment. Mainly, there are 4 points that we have to follow. The first one is what we call data extraction, and that's been to identify the entities, or in general, the metadata that we are going to use, and identify the source of that information. In the case of SAP, we will find out which tables are involved, which business object, which CDS views, etc. So once we have identified the metadata and from where we are going to get the information, the next step is do the modeling. I mean, to build your use case and define the relationships with the entities that fits better to use case. And for that, there is a standard that is called RDF, or RDF star. That is not new. I mean, is the people of the W3 concept are working on that since 25 years or so, so it's very mature, and they have a lot of possibilities. And you have to create the modeling using this RDF. The third step is generate the knowledge graph. So apply, execute some programs to extract the information and convert in the triples that you can store, or you can do it dynamically in a database. Currently, as I mentioned before, was not possible to store in HANA. And okay, I normally use this GraphDB graph database. And the last point that is quite important, because remember that at the very beginning I say that one of the challenges is how to provide the context of our enterprise to our LM model. Well, we have to provide an API, a connection, to be called by other technologies. Just to illustrate the first example, I put here what are the building blocks to identify the metadata. In this case, okay, the ABAP tables, the business object, the 3ds view, some of data services, and of course the documentation of SAP in this case. And we can build here the model that has to be made with RDF. Yeah. So in this slide, you can see how looks like the definition of the model. RDF use unique resource identifier, and that is using this URL. And to be sorted and to be, okay, not so boring, we use prefix to define a lot of things. And then you can see here that at the very beginning, we put the prefix that we are going to use for the classes, for the entities, and the one for the properties. I mean, we are specifying the source at the definition of task entities and the relationships, and we start to use the RDF. Basically, we use triples, you can see here, but we reference to a namespace where it's defined. In the case I showed you in the previous slide, you see the table echo that is defined in this namespace, and we relate with purchase order that is defined in this namespace that is defined here, and using this relationship that is defined here. So in this way, you build the model in RDF. RDF, as I said before, is very powerful, has a lot of possibility, allow us to work with an entity defined into two different sources. That is what we call RDF vocabularies. For instance, imagine that we are working with the purchase order or the purchase contract, and we have some attributes that are coming from the S/4HANA and other attributes that are coming from data services. So we use the same name of the entity, purchase order, but we specify a different source. That is what is called RDF vocabularies. And this language also have, or this framework also have a language to manage with ontology, that is OWL, or have another language that's for verification, this cycle, for instance, to define the cardinality between the purchase order of the vendor that has to be end-to-one. Well, okay, using this language, you can be completely sure that all the triples that you are defining are compiling with the ontology. Okay. Here I put just a sloppy ABAP to do that. On the left side, you can see that here are the definitions, it's ontology, the definition of the classes, the definition of the relationships, and here the definition of the triples with metadata in general. And on the right side is a very simple ABAP that reads the information, builds the triples, and transfer, export that information to in this case, an external database. From the 1st of April, we could do this to the HANA Cloud knowledge graph engine. Okay. As I say, once we have the graph, we have this powerful query language that is called SparkQL that allow us to access to the data. It's quite simple. It's very similar to the normal SQLs. You use variables, and you are traversing the nodes of the knowledge graph in order to get information. In this case, you can see that here I asked for all the subjects, all the objects and all the relationships that are linked to this purchase order. Yeah? But that is very simple. We get the results, and we can export these results in a JSON format and to pass to a CAP application, for instance, and put a nice application on there. Okay, that is just an example of how to represent more complicated queries. In this case, you have to cascade all the information and get more. But just is to show you how this looks like. And the last part is how to use knowledge graph. I put here two examples. The first one is in the supply chains. You know that in the supply chains there are a lot of actors. And just to simplify, I put only three: a retailer, a manufacturer, and logistics operator, in this case a carrier. And the idea is to work in the same language all the actors that are playing in the same supply chains. And for that, we use a common ontology that say which are the entities that has to be used and the relationship between them. In this particular case, I put an example. Imagine that there is a need for the retailer, and this retailer create a purchase order. So automatically is created, is updated the knowledge graph in the retailer system. And okay, some fields are coming from the ontology, and we have to specify that this purchase order, the seller is the manufacturer is YZ and the retailer is ABC. And in this particular case, we have two positions in the purchase order with two materials that are encoded in the retailer system information. This purchase order goes to the manufacturer, and the manufacturer creates the sales order and update his knowledge graph. This knowledge graph is only in the manufacturer system, and update his knowledge graph and put in and fit in some information that are defined in the ontology of the supply chains. In this case, the seller is manufacturer XYZ, the retailer is this one, and this manufacturing is going to use carrier to ship the goods to the customer. So in the system of the carrier, again, is created automatically this this delivery order and fills some some fields coming from the ontology of the supply chains. So every actor is maintaining his own knowledge graph, but we can put in the supply chains a federation of the three knowledge graph. And by doing that, we can provide in the in the supply chains the possibility to to make queries that are reading the knowledge graph that are not in the supply chains, but in the final system of the actors. Here I put just an example. Imagine that the retailer wants to know the status of the system, and he used his purchase order number because it's the data that he knows, and run this this query and get. In this case, I say that please give me the purchase order. Where is it? Here. The purchase order, the sales order, the delivery number, and the status of the delivery, and get that information. Yeah? The same query, exactly the same, can be run by the manufacturer, but in this case, they use the sales document number. That is the information he has. But it's exactly the same query and gets the same information. So that's it. Okay, yeah, okay. The last one, the other use case is how can knowledge graph can help to the LLM models. And for that, okay, let me just 1 second to say how can we classify the cognitive systems. The first classification was proposed by Alan Turing, but Judea Pearl introduced this ladder of causation. So dependence of the answers of the question you made on a system, a cognitive system, you can classify in 3 levels, in 3 rungs in the ladder. The first one is those systems that have the ability to recognize patterns based on the observation. And this is where GenAI is currently in this step, and is the step or the level of many animals. Imagine a predator that studies the behavior of the prey and can anticipate the movement or the next movement of the prey, and we consider that this animal is very good hunter, but this animal doesn't know exactly why the prey behave in that way. So can find associations, but cannot respond question at what if I change something. That this is the second level. This is the level of intervention. Okay, that is very familiar for us. For instance, if we have a headache, we know that if we have an aspirin, we break the chemical balance of our body, and thus mitigate the headache. So this cognitive system knows what happens if I change something. And currently, the GenAI models are not in this model, but knowledge graph can help to this GenAI model because GenAI, so let me go. GenAI can not only store entities relationship, but also can store the causal model for that. And here, just put on the last example is the last. And I have a supplier X that has a lead time of 40 days. This supplier supplies the component Y that is required for this assembly line. And this component has an inventory level of 300 units, and the production rate of this assembly line is 60 cars. So here the challenge is what happens if we change the lead time of the supplier. And that can be done in a knowledge graph, because in RDF there are this language that is called semantic web rule language that allows to set up the reasoning. And if in this query we are changing this value, we see what happens. So the idea is that the connection, the foundation models or knowledge graph can provide this second level of the classification of cognitive system. The third level, okay, I don't have time to explain it, but it's the capacity of the system to imagine things that didn't happen or will never happen. That is counterfactual. And that responds the question, what if had happened that, but in the case of supply chains, we can say, what would happen if we have switched that provider or that supplier by other one? So to answer these kind of questions require another level, and we are very far away in the foundation model from this. So thank you very much, and I hope that you enjoyed the talk.
I'm part of the Cloud ALM team in technical support organization. And the purpose of this presentation is to try to show you how SAP Cloud ALM can help customers, our customers, to implement and operate intelligent cloud and hybrid business solutions. Okay, let's go. This is the agenda for today, for the session, okay? The agenda has 3 main blocks. The first one is why SAP Cloud ALM, why to use this product. The second one is SAP Cloud ALM for implementation, and the third one, SAP Cloud ALM for operation, that are 2 of the main core capabilities of this product. So, okay, let's go. Okay, why to use SAP Cloud ALM? Okay, let me show you here the key benefits of using SAP Cloud ALM. SAP Cloud ALM is a single cloud native platform to manage the entire life cycle of the customer's SAP solutions. This is the first key benefit. The second one is that improve the collaboration between the different the members of the organization, among the different teams involved in the projects, from developers, testers, business lead, business user, IT operations. The third one is that it reduces the risk, because it helps to mitigate risk associated with implementation and operations. The fourth one is the cost optimization. It can help to reduce the overall cost of managing SAP systems. The fifth one is that it supports various deployment models, including on-premise, cloud, and hybrid SAP solutions. And the last one is the continuous improvement by providing tools as insights. Okay, let's go deeper with the capabilities of SAP Cloud ALM. These are the 4 capabilities of our product. The first one is implementation. It's a unified support for implementation and maintenance of SAP solution, covering all the stages from design, development, test, and the deployment of changes to production. The second one is the operations part. The operation part is it's helping to proactive problem detection for integration, exception, jobs, performance, business process, and so on. The fourth one is services. It's a collaborative platform workspace for consumption of SAP services. And the last one is transformation to manage the clean core projects in 5 aspects: business processes, extensibility, data, integration, and operations. Okay, let's go ahead. As you can see here, SAP Cloud ALM product enables you to build, run, and optimize your intelligent enterprise. How? It helps to adopt the latest innovation with the implementation part. It helps to keep your business running with the operation core capability. It helps to optimize with SAP services with the services core capability. And it helps to transfer to clean core with the 4th capability. Okay, another important thing that I would like to mention is that this platform is included in most of the SAP contracts, as most of you already know. So if the customer has already a cloud subscription, the SAP Cloud ALM is there. So they have an entitlement, and they can go to the SAP for me and just start the provisioning. So I will show you later the fair users rights that are included in the subscription. Okay, let's go ahead. Let's go to talk about the SAP Cloud ALM for implementation. SAP Cloud ALM enables you to build your intelligent enterprise. As you can see here, it covers all the steps, all the stages, from design, build, test, and deploy. Let's go a little bit deeper, but not so much. I mean, this is a quite quick overview. These are the main core capabilities about the SAP Cloud ALM for implementation. We have the processes, the task, testing, and chain deployment. I don't want to go into much detail, but just a brief overview in the processes, features, you can manage the SAP best practice content, what we call SAP Activate Roadmap, model process diagrams to conduct effectively the fit to standard workshops, and we can also manage requirements. In the task part, we perform configuration activities, manage extension, following always the SAP recommended task. In the testing part, we can manage the integration and user acceptance test based on manual testing and automatic testing. And the chain deployment is, it can be used to manage and to consistently deploy all your changes to production using the chain management workflow. Okay, this slide just is a quick summary of all of the capabilities, of the core capabilities of this implementation part. I don't want to go into more detail here because I would like to give you a quick overview in a short demo in one SAP Cloud ALM tenant. Okay, so here we have the process content, the process scope plus requirements is the project scope, the requirement, the user stories, the features, and so on. In the test management part, within the SAP Cloud ALM implementation capability, we can orchestrate the testings with test planning, test case creation, automated functional testing. We are integrating with two tools, as you can see here, the test automation tool for SAP S/4HANA Cloud Public Edition and Tricentrix Test Automation for SAP Cloud ALM. Okay, in the deployment integration part, this is the current picture. So we actually integrate with the pure CTS that I'm pretty sure that you already know, for on-premise ABAP system and the S/4HANA Cloud Private Edition, ATO, Adaptation Transport Organizer, for the S/4HANA Cloud Public Edition and Integrated Business Planning. And also we have the integration with Cloud TMS, the service for the SAP Business Technology Platform. All the dotted line that you can see here is that the integration that is planned, and also for the ATO, we have further transport related actions planned for the future. Okay, just to give you a summary of the customer benefits during implementation. As we have talked, SAP Cloud ALM helps you adopt the latest innovation by effectively conducting fit to standard workshops, easily onboard your project team, your member and your project teams, automate task assignment. You can manage all test activities. You can also coordinate the deploys to production. All on top of that, you also have the maximum traceability end-to-end and track progress with built-in reporting. Okay, let's go for the demo. Let me stop sharing this presentation and let me go to the system. Okay, continue working. I would like to show you first of all, let me see. Here we have an SAP public Cloud ALM tenant that you also have access to it. Of course, I will share you some useful resources and links. Okay, here we have the home, the launchpad for the SAP Cloud ALM. Here we have the implementation tab, and each of every tile is providing you with the features that we have discussed before during the presentation. Here, for example, in the overview tile, we have a quick overview of our project with quite useful information during the implementation of the project, okay? Let me go back. Let me show you the projects and setup. Okay. Let me go for the project and setup. I go to our internal SAP Cloud ALM tenant. I don't want to modify the other one. Even I don't know if I have authorization, but just in case. Okay. This is the projects and setup part. Here I have created for this demo a project. As you can see here, you have a general information. I use in the SAP Activate Roadmap, I use the S/4HANA Cloud Public Edition 3 System Landscape Implementation, just as an example, okay? But here, if you go there, you can see all of the available one, depending on your needs, on your requirement, on your project implementation, and on your scenarios, okay? Here you have the access level for your project. There are three levels: public, restricted, and private. You can also integrate, for example, with the CVC in the case of S/4HANA Public Edition. Here in the time boxes, we define the phases with the time frames, the sprints, the milestones, and so on. Here you can assign the teams and the different roles within the project that have all these members. In the scope, here, for example, I created also a scope for this presentation. And in this scope, having in mind or keeping in mind that I selected the active roadmap for the S/4HANA Cloud Public Edition, and I activated for my project, for my implementation project, I activated these 3 scope items. Okay? You can go to manage scopes and add everything that you need for your, yeah, here you have the process scoping. Okay? Here, I have activated this best practice for S/4HANA Cloud Public Edition, but if you go to process scoping, you can select every scope item that fits with your project and fits your business function and your needs. Okay, let's move back quickly to our project, deliverables, deployment landscape. Here, the deployment landscape tab, it shows you the system group that is created for the change deployment. Let's say that to move the changes up to production. In this case, we have a system group with S/4HANA Public Cloud Systems, 2 developments, the development, and development customizing. It's the concept for S/4HANA Cloud Public, the quality assurance, and the production. This is a 3-system landscape. Okay. Let me see. And then I would like also to show you the requirements. I created also a requirement. Let's go. Associated with this project. Okay. Here, I created my requirement associated with this project, with this scope. And I have 1 user story, and I have also 1 feature. And from my feature, if I go to the transport tab, okay, I can assign my transport request created in the S/4HANA Cloud Public Edition system. Okay. Okay, let's move on. Back to the presentation, I think, just in case we don't have enough time. If we have time, maybe we can check a little bit more later. Let's see. Okay. After the quick demo for the implementation part, let's move on to the third part of the agenda, the last one, and let's talk about the SAP Cloud ALM for Operations capability. Okay. This one is enable you to run your intelligent enterprise. This means that once you have already completed your implementation project of your system landscape, you have already your solution or your product running, operative, and then you want to keep your business running. I mean, you want to minimize risk. Okay. Here is how the operations part of SAP Cloud ALM can help with these 4 core capabilities: the detection of problems, avoid anomalies with proactive problem detection, conducting root cause analysis, increase operation efficiency by automating corrective actions, and then use the collected data with artificial intelligence to automate operational tasks and predict anomalies. As you can see here, SAP Cloud ALM drives business continuity in your SAP landscape by monitoring and alerting. Okay, this is a quite big picture of the functional overview. Here we are representing the available, what we call use cases in operation, in monitoring use cases. We have, I think that more or less we are covering, I wouldn't say everything, but a good part of what is needed during the operations of the SAP landscape and solutions. We have the business process monitoring to make sure that all the business processes are running correctly. The integration exception monitoring, the health monitoring, that is checking the health of your SAP systems, cloud or non-cloud systems. We have the job and automation monitoring, is more focused in the jobs executions. Also, we have the intelligent event processing, that is processing the events that are coming from all of these monitoring use cases. And then with these events, we can, with the alert management, we can manage the creation of alerts. We can also send email notifications. We can also create tickets, for example, connecting with with an API to a ServiceNow, a third-party tool. And we can also, we have also the operation automation by triggering workflows. I know that this is a quite high-level overview, but we don't have so much time to go in detail. So again, SAP Cloud ALM keeps your business running, and the customer benefits during operations are that they are empowered customers to understand their own, the healthiness of their own SAP systems, provides full stack monitoring, as we could see in the previous slide, alerting and covering also business processes. We can also conduct root cause analysis on different levels. Let's say that we have, this is a collaborative platform between all line of business and including IT. It increases operation efficiency by automating corrective actions, predicts anomalies, which is quite important, and provide transparency regarding availability of business services. Okay, let's go for the demo. Let me escape the presentation. Let's go for the demo. Let me show you in this previous SAP Cloud ALM tenant that we have. Let me go to the home page. Okay. Here I would like to show you also briefly the landscape management. The landscape management is the place where all the SAP services, system, business services connected to the customer are stored or are placed. Okay, here we have everything. Based on this landscape management, then we go for the operations tab. And let me show you, for example, the health monitoring for several systems. The health monitoring, in this case, for example, we can see here an SAP Solution Manager system. This is a on-prem system, an ABAP system. In this case, the data collector to send the information to the SAP Cloud ALM for the monitoring and so on. It's what we call push, because this system, there is a specific configuration done in this ABAP system. We activated the monitoring use cases that we want, in this case, health monitoring. And then the data collector is running and is sending the information to the SAP Cloud ALM. Let's have a look. Here at this system, for example, this one, here is the data collection. The data collection is running. Let me show you, for example, some of the metrics, the metrics overview. This is a pure ABAP system, it's a solution manager system. So we have, for example, the ABAP license, the work process on hold, the work process stopped, number range, certificates. It's having a HANA database, so we have here few metrics to also operate and control that. We have here the ABAP resources, for example, extended memory, heap memory. Okay, the configuration for this one, I think it's pretty straightforward. I mean, I don't know, I want to configure the metrics, the threshold for the extended memory, then I configure here, I select my usage, when it should be a warning, when it should be critical, and so on. And then in the events, here in the ABAP memory, I also decide if the threshold is consumed or it's reached. Then what I want to do, I want to create an alert, I want to create an alert and send an email, I want to start an operational workflow, or I want to create a ticket in a third-party tool, like, for example, ServiceNow. This is one example of health monitoring. Let me see, we can see also another one. For example, for the job and automation monitoring, we have here as well several ABAP systems. Let me select this one, for example, I don't know. We have here an overview of the jobs or automation that are running in the system. Here we will have the alert tab showing all the alerts generated. Let's have a look at one of them, for example. Here we have the alerts generated when this specific job is running, and depending on the threshold configures and so on, the alert is generated and is showing me information about the alert. If I go back, I'm going to select maybe this system, just to show you quickly any of the alerts here in the alert details. Come on, I don't know, for example, this one. Here I have in the alert details, I have the run ID. The run ID matches with the run ID of the corresponding job in the SM37 in the system. So if I click here, I should be asked for logon into this system. Let me go again. Let me go click on the specific alerts for this Solman system that I'm pretty sure that I will have access. I hope. Okay. No, it's something wrong with the network, I think.
So proceed, click advanced.
Advanced, okay. Yeah, proceed. Yeah. I cannot, I have another. Hear me? Okay. Here. Okay, here I log on to the solution manager system, and I should go directly to the job execution that has been delayed. Okay, let me see what we can see. Let me go for other SAP Cloud ALM. I don't know, maybe this one, because here in the business process monitoring that I would like to show you in the operations part, the business process monitoring, we have here business processes. I have, okay, I don't know, for example, this one, purchase requisition items created. Okay, here I have all the purchase requisition that had been created in this my S/4HANA Cloud system. If I go to the configuration, I can see the managed components, I can see the services and systems with this business process monitoring activated. Here in the KPI management, I can do the configurations. Let's see, for example, this one. Go into this, and I can also do the configuration of the events. The data collection is switched on, and so on and so on. Okay, let me go back to the presentation just to go ahead. Okay, your next steps. I really encourage you to try to use and to configure the SAP Cloud ALM, because it's something that is there for you. I mean, you just only need to go there and start provisioning and start using it. And Here I provided you some links about how to learn, try, because this is a public demo system, the one that I just showed you before with the business process monitoring. This is the part of the request and the use with the setup to set up your user in the SAP Cloud ALM and so on. Here is a summary. The last slide is a summary of all useful links related to SAP Cloud ALM. I would like to show you one of them, this one, SAP Cloud ALM for Operation Expert Portal, which is, let's say that this is the, in the operations part of the SAP Cloud ALM. This is a live document. Let's say that developers and development is updating this document constantly when there are more SAP solutions supported, when there is more content supported for every monitoring use case. This is the starting point. If you are going to use the operations part of SAP Cloud ALM, this is the starting point for the configuration. I mean, you need to go here. I don't know, you want to activate business process monitoring for whatever SAP solution or product or system or real-time monitoring or the health monitoring, you need to go to this page. You need to go here, and you need to read everything. And what is very important is the setup and configuration, because everything is documented here, and this is a live document. And we also ensure that everything, anything that is now available, that is delivered or whatever, is placed here. Okay. Let me see if we have anything else. No. Question and answers section. Yeah.
There was quite some functionality about business processes. So I was wondering, the integration, is there any integration with Signavio? Because, how should I say, best practices or best implemented processes I would have located
Yeah,
in the Signavio
there is
solution.
integration with SAP Signavio and LeanIX.
Okay.
Yeah. Just one important thing, I forgot to mention that today here is attending also this session a colleague of mine, Dolores Correa. Maybe some of you already know her. If you don't know her, she's the go-to person for solution manager and Cloud ALM world. Okay. So just to finish I don't know, there are any questions? Any more questions? No? Okay, just to let you know that, okay, we are here. I mean, we have here in Madrid, we have a Cloud ALM team in technical support. So if you have any question, any doubt, anything that you need, that you miss, just contact us, because I mean, it will be a pleasure to help you. And we also want to hear your feedback about this product, okay? Because we are here to try to improve it as well. So we have a very close contact with developers, and we would like also to hear and to get your feedback, okay? That's all.